Okay, here we go. Lesson 5, Unit 6, Lesson 5. We're going to be talking about angle, side, and side, angle, side similarity postulates. So this one you should know from last lesson, but angle A is congruent. Oops, that's not angle A. Angle A is congruent to angle D, and angle B is congruent to angle E. Therefore, we can say that these triangles are similar because of the angle postulate. So it's kind of like that side similarity theorem. Angle or line AB is the same as line DE, it's not the same, it's proportionate. And line BC is proportionate with line EF. They're the same. And we also have line AC is proportional to DF. If they all have the same proportion, then you know that they are going to be similar. And that's side similarity theorem. So again, as long as it's proportional, they're not necessarily going to be the same sizes because they're only similar. They're not congruent. And the last one is side angle side. Notice that our angle is sandwiched in between of our two sides. Okay, that's super important. The angle that's congruent has to be the angle that's in between the two sides in order for this to be true. Side angle side similarity theorem. And again, this is looking at the ratio and the proportion. Are they proportional to each other? Okay, so looking at this, so I have all these different numbers. I'm going to notice that they're all different. So I'm going to have a longest side, I'm going to have a medium, and then I'm going to have a short side. So that's how I'm going to always match them up. So right now, what I'm going to do is I'm going to compare short to medium. So I'm going to find the proportion of all of these triangles looking at the short side to the medium side. So my shortest side over here in my smallest triangle is LM, and then it's RS, and then it is YZ. And then my shortest or my medium side on this triangle is MN, RT, and XZ. So let's put that into some writing. So I'm going to say LM 20, so short over medium is 20 over 24 equals 24 over 30, which equals 30 over 36. So I'm going to go ahead and simplify these down or just turn them into decimals. 20 over 24 is 0.833. We'll just simplify it. So I'm going to take out a 4. This is going to be 5/6. If I factor out a 4 of this one, actually I'm going to factor out a 6, divide it by 6. You should get 4/5, so that's not the same. And then if I factor out a 6 of this one, I get 5/6. So looking at this, it looks like I have 2 that are 5/6 and then 1 that is 4/5. So I would say that triangle LMN is similar. This one right here is similar with this one, not similar with this one. So again, L and M, that's my short side going to my medium side. The order matters, so I'm going to say Y, Z, X. Find the value of X that makes this true. So again, AB are my first 2 letters. That corresponds with DE. So AB and DE, okay? I'm going to use that. I'm going to say 4 over 12. And now I want to think about, okay, where is my X values? Well, I see I've got BC as X. So if I look at BC, that's my second and my third. So that needs to match up with EF, BC, EF. Oh, we can do that. So that's just equals x minus 1 over 18. I'm going to cross multiply. Don't forget to use parentheses because you will have to distribute. 18 times 4, 72. 12x minus 12. Add 12 on both sides. 84 equals 12x divided by 12. And you get x equals 7. So all the question asked me was to find x, but again, if I did 7 minus 1, that would be 6. If I did 3, 7 plus 1 is 8. That would give me 24 there. So I could just as easily find the sides. All right, last but not least, are these two triangles similar? Well, let's see. Can we use side angle side? So really, I have a vertical angle here, a vertical angle here. They're congruent. I need to determine, are these numbers proportional with each other? So I'm going to set it up as 14 over 21 equals 18 over 27. And my question is this the same? If I divide the left side by 7, I get 2/3. If I divide the right side by 9, I get 2/3. So yes, our sides are proportional. They have the same ratio. So we have a true statement. Now we just have to write it. So I'm going to keep C is going to be in the middle. So I'm going to say triangle ACB is similar to triangle DCE.